I'm not sure what first started me looking into garage door remote technology, but once I started digging into the history and seeing how the security has evolved over the past few decades, I was blown away by what I've learned. If you've ever been curious as to how secure your own remote is, keep watching. I think you'll find this video quite interesting. It's hard to believe, but as of this year, 2026, the electric garage door opener is 100 years old. In this video, I'll be focusing on the early history and security evolution of garage door remote technology. In my own lifetime, I've seen where these opening systems have been kind of a joke when it comes to security. They would open up on a whim versus today, as you will learn in this video, the fact that these garage door openers are virtually unhackable. This video is the first of at least 2 or 3 videos. I plan additional videos covering in more detail the evolution of the radio frequency technology used over the years. I'll have another video covering the durability and reliability of garage door opener remotes. And finally, there'll be a video covering troubleshooting garage door remote issues. But first, let's go back in time a bit. Let's rewind the clock and see how this all first began. In 1921, C.G. Johnson, founder of the Overhead Door Corporation, invented and began to market the overhead garage door. Seeing how some people struggled with opening these doors, he then invented the first electric garage door opener in 1926. Early systems were essentially motorized mechanisms controlled by a switch. The units were entirely wired. A button on the garage wall or a hardwired exterior switch on a post triggered a motor that would pull the door up via chain or belt system. These systems had the obvious security weakness of allowing anyone to potentially open the door. So to prevent that, various forms of key-operated exterior switches, coded keypads, and even intercom control systems were developed. Surprisingly, the first wireless systems came out just 5 years later. These were not consumer products, but rather custom-built items made by wealthy experimentalists. These early systems used a version of spark gap radio technology. Spark gap radio transmitters were notorious for requiring considerable bandwidth. Basically, a spark gap transmitter, if transmitted into the open air, could wipe out an entire radio band. Thus, as a general radio technology, the use of spark gap had been phased out and made illegal during the late 1920s. However, in the early 1930s, the early experimenters who wanted to use this technology were able to stay compliant with federal laws by using inductive or electromagnetic ground coupling. In these systems, the transmitter used a spark coil connected to a loop wire beneath the front bumper of the car. When the driver pulled a wire or pressed the dash button, it created a powerful spark that could be picked up by the corresponding receiver loop buried just under the driveway's surface. Because the signal was localized within a couple of feet, it didn't radiate broad-spectrum interference into the airwaves. I suspect that these early spark gap opening systems did create a little bit of interference in the immediate neighborhood. But when you consider the amount of RF interference a late 1920s car produced, with its unshielded wiring, non-resistive spark plugs, mechanical distributor with arcing contacts, and a third brush generator rather than a true voltage regulator, the amount of interference created by one of these spark gap opening systems would be minuscule by comparison. In fact, because these late 1920s, early 1930s cars were so noisy, these spark-based inductive systems typically used a spark in the range of 15 to 20 kilovolts. and some were sophisticated enough to be set to generate 3 timed pulses over a 1/2 second period, with the receiver being set accordingly to only activate the door upon receiving these 3 timed pulses. This kept the car engine itself from accidentally triggering a door activation. Here's a link to a 1933 Radiocraft magazine article about one such system. I'll include this link in the program description. With the commercial development of the transistor still years away, the first garage opening remote units available after World War II were mainly vacuum tube based. These portable remotes were basically a lunchbox-sized item in the car. Thus, many units were made to be mounted under the dash of the car. A portable unit required a vacuum tube, a low-voltage filament battery, a high-voltage B battery for the tube's grid voltage, and a coil tank circuit along with a metal chassis or case. Some under-dash systems could be wired into the car's electrical system, thus not requiring the additional batteries. This is just one of many ads that I've found showing that there was a commercial market for garage door systems in the 1940s. At first, I questioned whether this ad really was from the 40s. As you can see in the picture, a double-wide garage door. But it turns out the garage door opener industry was catering to the more affluent families at the time, and several of them did have these big, heavy, wide doors. I know from personal experience that these sectional doors were extremely heavy to lift. Thus, there was a greater need for those families to have an automated door opening system. I looked for a portable transmitter, tried to find something online that I could show, and I couldn't find any such thing from the 40s. Virtually all the ads I found had these in-dash, probably mounted under-dash, garage door opening remotes. Using radio frequencies for garage door opening units right after World War II was definitely operating in a gray area as far as laws and regulations were concerned. That's because at the time there were no regulations for where remote control operations like garage doors could even operate. Also, with the vacuum tube technology requiring these lunchbox-sized opening units, some manufacturers chose to adopt the use of ultrasonic technology. This avoided any problems with FCC regulations and eliminated dealing with the bulkiness of early electronics. I found this ad for an ultrasonic system in a 1952 Sears Fall and Winter catalog. What's interesting about this system, it's vacuum powered. It runs off the car's manifold intake vacuum, similar to several other car accessories at the time. In fact, my first car, an AMC Gremlin from 1970, had vacuum-powered windshield wipers. They worked great as long as you weren't accelerating. It's $170, which is, a pretty good chunk of change back in '52. There's an optional key post opener. Includes a key lock on a post, and that's $100 in itself. That seems rather pricey for what that is. It's just an auxiliary switch. It comes with an interior switch, of course, when you can close the door as you're heading into the house. I did not find this system advertised in any other catalog outside of the Sears 52 catalog, so I don't think they offered it for that many years. Though other manufacturers did have ultrasonic-based systems during the late 40s and first few years of the 1950s. For a proper perspective, I thought I would post some 2026 pricing to this Sears ad. As you can see, with the main unit costing over $2,100, these were definitely not a trivial item to purchase. The extra whistle you see there, which would be over $115 in today's dollars, was not a simple dog whistle, but obviously an entire assembly unit for a second car to have a ultrasonic transducer. These things were mounted entirely in the engine compartment with the ultrasonic speaker essentially as close to the front grille as possible, because ultrasonic waves generally do not travel through any solid surface. They tend to bounce off. There was a microphone in the garage. Usually it was mounted near the ceiling above the garage door, and it would pick up the signal from within the garage. Because ultrasonic waves don't travel through solid objects, the installer, when he would put a system like this in, would have to drill a hole through the garage wall to the outside and have an acoustic pipe attached from the outside and then routed into the microphone pickup unit that was in the garage. By having dual ports to pick up the sound, the installer could get by with just one microphone, which back in 1952 was a considerable expense. Now, these systems didn't survive the real world very long. They were only marketed, again, for a handful of years from the late 40s through the first few years of the 1950s. The problem was due to a number of things, but mainly it was just false activations. The jingling of car keys or squealing fan belts or brakes would easily trigger the door to come up or go down. Metal clanking, the rustling of leaves, even wind blowing through a screen door could trigger door activations. Birdsong was not a problem, but some people had problems if bats flew by. Keep in mind, bats use ultrasonic energy for their navigation, and that would trigger door openings as well. Manufacturers did try to add a little sophistication to their systems by requiring a number of ultrasonic pulses before the door would open. But this would create additional problems. People would have to press the button longer and wait for those pulses to complete before the door would activate. And really, it didn't solve a lot of the false activations. So many of these environmental sounds that were triggering door activations were pulse in nature anyway. Adding a pulse count before the door would activate didn't really solve the issue. There was one big flaw with these ultrasonic systems, and it had to do with pet distress. A large number of families, as you can imagine, have dogs, cats, guinea pigs, and other pets that are sensitive to ultrasonic sound. Having your pet go into distress every time you came home was probably not a selling point for these systems. While I don't think the pets were as well organized as you see in this illustration here, I'm sure that the dogs and cats of the early 1950s let their owners know just how disappointed they were with these ultrasonic systems. Around 1958, radio frequency opening systems pretty much displaced the last of the ultrasonic units. However, the remotes of this era were still quite bulky. They were now transistorized, but still quite large. These early germanium-based transistors required considerable current. Thus, while some of these remotes were mounted on the visor, similar to today's mountings, they had to be wired to the car's electrical system. Battery-powered visor-mounted remotes, such as what we're familiar with today, didn't really come about until the mid to late 1960s. These first battery-powered remotes were much like our units today, other than being a bit bulkier as they utilized a 9-volt battery. But neither the ultrasonic systems before them nor these early consumer radio frequency units have any security built into them. The garage door openers were simply triggered to open if they received any kind of steady signal on their assigned frequency. And the receivers of the day were pretty crude. It wouldn't have to be exactly on frequency. Thus, you could really only have one opener in an immediate area. If your neighbor bought a garage door opener system, chances are his remote would also open your door. Almost all of these units made throughout the 1950s, early 60s used frequencies in and around 25 to 27 megahertz. And this became a real problem once the FCC started the Citizens Band radio service in 1958. By the early 1960s, Citizens Band radio was really taking off. Commercial operators were using it big time, and there were a number of enthusiasts also beginning to adopt this new radio technology. My wife tells me a story that she recalls from the early 1960s. She was out in the Black Hills of South Dakota with her Uncle Richard. He was an early CB enthusiast. My wife remembers Uncle Richard taking her to a section of a small town in the hills and said to her, "Watch this." Then he simply keyed his CB microphone, just pressed the transmit button, didn't say a word, and about 3 garage doors popped up right in front of them on the street that they were parked at. This demonstrates the big problem, of course, that garage door systems had back then. And it wasn't just CB radios. Those who were living in the flight path of a busy airport would also experience unintended activations. I even have a story of my own from my own neighborhood that occurred in the early 1960s. In 1964, I lived in a neighborhood on the eastern edge of town. The local broadcast station, KBRK of Brookings, South Dakota, had their radio tower less than half a mile away to the east of our neighborhood. KBRK was a 1,000-watt AM radio station that was allowed to transmit from sunrise to sunset. Often at sunrise, when KBRK first came on the air, one of our neighbors who had a garage door opener would suddenly find his garage door opening. What was happening was that when the local station first fired up its transmitter each morning, it created a brief broadband radio spike that simply overloaded his garage door receiver. With the simple receiver technology that garage opening systems had at that time, that AM radio station first coming on the air each morning was the equivalent of a button press on the garage door's remote. In the latter half of the 1960s, garage door manufacturers introduced single-tone audio modulation. Instead of just firing a raw radio wave, the garage door remotes would modulate a specific audible pitch, an audio tone, onto the RF signal. The receiver contained a tuned analog filter designed to trip only when it heard that precise tone. This did solve the problem of radio stations from triggering door openings when first coming on the air each morning. While the introduction of audio tones took care of a lot of false door activations, mischievous and creative CBers found another way to trigger door openings. I remember it was about 1968, some neighbors of mine came over with their new CB base station. And they set it up on our front porch and they showed us what I'll now call the CB whistle hack. What they demonstrated was by keying the microphone and then whistling the right audio pitch, you could trigger somebody's garage door to open. Now, nobody really knew what audio tone garage doors were using in our neighborhood, but what you could do was you could key your microphone and then whistle a low frequency and then just climb up the scale, and somewhere along that range, you would often trigger a door activation. So to stop this mischievous CB whistle hack, manufacturers began requiring their systems to modulate 2 or more different tones. The receiver had to detect both the main RF signal and the shifting tone pattern before opening. This did stop the CBers from activating doors. But these early tone shifting systems were subject to component drift. The analog inductors, capacitors, and crystals in these early 60s tone-generating circuits would drift out of tune over time due to seasonal temperature changes, especially if you had an uninsulated garage. Homeowners often found their remotes failing in extreme cold or heat because the pitch the hardware wanted to see shifted from what the transmitter was sending. And that wasn't the only problem. To provide these different codes to customers, manufacturers had to build and ship physically distinct remotes and receivers with pre-soldered factory-set tone filters. Openers and remotes had to be matched making obtaining a replacement or an additional remote difficult. Due to this expense, rarely did a manufacturer offer more than a handful, maybe 5 or 6 at the most, tone combinations. And still there was no real security. If your neighbor bought the same brand garage door opening system that you had, there would be a fair chance that his remote would also open your door. During the 1970s, manufacturers addressed the shared tone code problem with DIP, dual inline package switches. These switch banks would exist both in the remote and in the receiver. Via these 8 tiny switches, an installer or homeowner could set a matching pattern for both the remote transmitter and the garage door opener receiver. Only remotes with the identical switch pattern to what the opener was set to could activate a given door. Tones were no longer used. Instead, these codes were transmitted in a simple carrier on-off manner, on-off keying, much like how Morse code works. The introduction of fixed codes was a huge step forward. It pretty much solved the possibility of your neighbor's remote or any other random radio source from activating your door. But manufacturers soon realized that 256 codes was still a bit limiting in being able to prevent a bad actor from gaining access to a garage. So they quickly upped the number of codes available, with most manufacturers eventually standardizing on a 12-switch binary system. With 12 switches, you could support up to 4,096 unique codes. Genie and Overhead Door, however, went a step further. They standardized on a 9-position trinary switch block, providing the ability of a user to select one of 19,683 possible codes. The last of the fixed code systems was Chamberlain quote-unquote billion code system. It was manufactured from 1993 to 1997. What Chamberlain LiftMaster did was pre-program the remotes at the factory. The Chamberlain LiftMaster billion code system was quite an innovation for its time. No longer did the customer have to worry about messing with any sort of dual inline package switches. Each remote was pre-programmed with its code at the factory and was unique. When the customer received his garage door opening unit and got it installed, there was a pairing process whereby a green button was pressed on the back of the receiver unit. This opened up a 20 or 30-second window where then remotes could be pressed and added to the receiving system. With 3.5 billion codes, you would think that we were at the end of our story here as far as making these systems hack-proof. Unfortunately, that wasn't the case. There was one major weakness that began to be exploited during the 1990s, and it was the fact that all of these fixed code systems were just that, fixed code. Each remote always transmitted the same repeatable code every time. In the late 1990s, it became possible for even a casual hacker to obtain extremely inexpensive devices that allowed one to either send all possible codes to the receiver or capture the code being transmitted by garage door remotes and then play it back later. This illustration here shows a capture device, but in practice, the brute force attack of trying all combinations was probably more common. It was time for the industry to provide a breakthrough to finally stop all hacking attempts. As the ability to brute force code transmissions became trivial, the garage door opening manufacturers were already working on a final solution by the early 1990s. Finally, by 1997, rolling code systems were introduced by nearly every garage door opener manufacturer. These systems essentially allowed only valid remotes to send commands to the garage door opening unit. Additionally, every time the button was pressed on a remote, the remote transmitted a one-time use code that would never be used again. Each garage door opener receiver knew what values to expect from each registered remote. Anything else would be rejected, and each code could only be used once. As with the earlier LiftMaster billion code system, these new rolling code systems all came with a learn or pairing button of sorts. During the pairing process, typically a 20 to 30 second window, you can pair up new remotes to a specific garage door opener. Only such paired units would be recognized by the opener, and enough information was transmitted to the receiver so that it would be able to calculate what values to expect from each paired remote. Now what's interesting is the number of combinations. Here's a facsimile of the data fields that are sent to the receiver every time you press your remote. It's basically just a approximation. One thing I've discovered is when you try to investigate the specifics of how these systems work, you run into a lot of roadblocks. Obviously, the garage door industry doesn't want to reveal its secrets. But when you consider the scope of the data fields here, you've got almost 60 bits of information or more that has to be sent on each button press. There's no way anyone can send all possible codes because we're looking at trillions and trillions of values potentially that would have to be tried in order to have a success. All the hacks that I'm aware of require physical access to this remote. Even the university labs that have found some side channel hacks have to spend several hours with special lab equipment with your remote in hand before they can come up with a hack. And despite all that, Chamberlain LiftMaster upgraded their system in 2011 to address all of those academic side channel hacks. So now those aren't even possible. In fact, the data fields I just showed you a minute ago, that was all 1997. The 2011 system that LiftMaster came out, they expanded that rolling code field to somewhere between 80 and 128 bits. Again, the information is vague because they don't want to reveal the specifics. If you have a garage door system manufactured on or after 1997, you can sleep well knowing that you've got an extremely secure, essentially unhackable system. As long as you have secure possession of your remotes, you're good. There have been continued developments. Just recently, in 2025, LiftMaster has come out with Security 3.0 Plus, and some of the other manufacturers have done additional things too. They all seem to be in lockstep with each other, trying to outdo each other. I'm not a big fan of some of these new security measures. Right now they're getting into using two-way handshaking, similar to Wi-Fi. That's okay to some extent, but a lot of their new features rely on Bluetooth technology or internet connectivity, and I'm not a fan of that at all. I'm especially wary of Bluetooth because, like in my neighborhood, Bluetooth is very unreliable. The congestion on the 2.4 gigahertz band is considerable, and most Bluetooth devices, at least in my immediate area, don't work well. In any case, the days of a hacker hacking into your garage door system by capturing codes or trying a brute force approach, those days are long over. If you enjoyed this video, I hope you'll give it a thumbs up. I plan a couple of follow-on videos, possibly 3. I'm not sure how many videos, but the topics that I'll be covering next will be the evolution of radio frequency technology in relation to garage door remotes, as well as the durability and reliability these systems have developed over the years. Finally, I'll do a separate video on troubleshooting garage door remote issues. As I get these additional videos done, I'll post them here on this end screen. So look here, and maybe down here to see what videos pop up. Hopefully over the next few months here as we wrap up 2026, I'll have finished this series. Thank you again for watching.